Hello friends, it's Dhananjay here, and today I'm going to teach you how to make a gesture-based robot. To see how to build the chassis of the robot, please wait for a further upload in which I'll show you how to make it. As for today, I'm going to show you how to enable your gesture-based robot. So, what is a gesture? A gesture is any movement that you make, especially with your hands. And what we're going to learn today is how a robot can track our hand movement in such a way that it coordinates its moves accordingly. So how do we convert our hand movements into digital signals that the robot can understand? So uh, a simple application of this would be like when we have a phone and we turn it from vertical view to horizontal, and the whole picture just switches. It's done with the help of an accelerometer, and such a thing tracks changes in acceleration. So that is what we're going to be implementing over here. So the accelerometer that we're going to use over here is an ADXL335 accelerometer. This is what it looks like. So that's the first thing you're going to need. You're going to need for now two connectors double sided. You're going to need a 2-pin connector, probably a wire stripper if you need one, or you can just use your mouth. And you're going to need an 8-core wire. Alright, and preferably with the colors black, brown, red, orange. So our accelerometer, the ADXL335, can only handle analog signals, right? So but our development board and our microcontroller cannot understand analog signals, and they need to be converted to digital signals. So what are analog signals? Analog signals are signals which can vary. They can have a high point, a medium point, a low point, whereas digital signals can only have one steady high point and one steady low point. And so we need a method of converting from the very fluctuating nature of analog signals, which our ADXL335 accelerometer gives us, to something more steady. So we use something called an op amp. An op amp is something which is used to compare, add, subtract voltages, and basically in our case to give us to give us digital signals, which is one high value and one low value of output voltage. So on our development board, we don't see in this development board at least, we don't see an op amp being used directly. We use something called a comparator, and our comparator, which is LM324, contains 4 op amps in it, and so thus it can handle 4 different signals. So how does an op amp work? Uh, so an op amp contains 5 pins. The ones that we need to know about are the 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 non-inverted pin and the inverted pin. So the inverted pin is the pin in which we will feed our reference voltage. So, and I'll get to that in a sec. And the non-inverted pin is the one that receives a voltage from our ADXL 335. So say the voltage in the non-inverted pin is more than the reference voltage or the inverted pin voltage, then it returns a higher value, a set higher value, and if it's lower, then it returns a set lower value as output. And this is according to the development board. In our case, the high value is 5 and the low value is 0 volts. 5 volts because the development board, in this case the Sky-Fi Labs development board, requires 5 volts. So uh, now to break down the specifics of our accelerometer, it's a capacitive accelerometer, and the advantage of these is they're fairly functional, flexible, and they're comparatively inexpensive. So it basically works on the principle of capacitance. So it contains 2 capacitors in it. One is the fixed plate capacitor, one is the variable plate capacitor. So when we move this, the distance of separation between the two plates of the non-fixed capacitor changes. So this changes the voltage that it lets out, and then it goes through our comparator and it gives a steady 5 or 0 volts. So take your 8 core cable and split it down the middle so as to have two 4 core cables, right? So just like split it. Just like that. Yeah, so these are the two cables that you should have. Now toss aside this one because we don't need that at the moment, and take this cable, the orange, red, brown and black. Alright, now get your wire strippers, or if you prefer to do it with your mouth, and split the wires from both sides. I've already done it in advance. Okay, so get your connectors, get your connector and cut it down the middle, and you should get two like these, right? So connect one of them to the brown wire and connect the other to the black wire as shown. So first, as for the other wire, and be sure to cover these with electrical tape later on, right? First, right? So one side of this is gonna connect to your development board or your Arduino, and the other side is gonna connect to your ADXL 335. Okay, so next split another one of your connector cables down the middle like this, and you should get two like these, and yeah, and similarly do it to the orange and the red cables. Connect them. So first connect this to the orange, and connect this. Connect this to your red.